The acetylene, or also called by the International Union of Pure and Applied Chemistry, ethine, was discovered by the British chemist Edmund Davy in 1836. Davy obtained the gas accidentally when he combined water with potassium carbide. While attempting to make potassium metal, he noted that the gas burned with a bright flame and thought it may be used as a source of illumination. That application was impractical, however, because of the high cost of potassium carbide. When the German chemist Friedrich Wöhler discovered the far less expensive calcium carbide in 1862, however, that problem was solved, and the demand of acetylene in lamps and other applications grew quickly. Physical and chemical properties. It's a gas, odorless and colorless, have a molecular weight of 26.038 grams per mole, a density of 1.097 kilogram per cubic meter, a boiling point of minus 84.7 degrees Celsius, and a melting point of minus 18.8 degrees Celsius.
In petrochemical, acetylene is obtained by quenching with choline, a natural gas flame or volatile fraction of petroleum with high boiling point oils. An alternative synthesis process is the reaction of water with calcium carbide. The general reaction is as follows: 1 mole of calcium carbide and 2 mole of water produce 1 mole of ethine or acetylene and 1 mole of calcium hydroxide. The synthesis of acetylene is through an electrophilic addition reaction. First, the two pairs of oxygen electrons attacks calcium in this bond with carbon is broken, and the calcium oxide bond is formed. Oxygen is positively charged, thus stabilizing when the proton leaves to join the carbon atom. We obtain this molecule, and with another water molecule in the same way, oxygen attacks calcium. Oxygen remains positively charged, so it's stabilizing when the proton leaves, which is added to the another carbon. The calcium carbon bond is broken, and finally, we obtain ethine and calcium hydroxide.
This odorless and colorless gas is used in combination with oxygen for industrial welding and oxyfuel processes. For use in industrial processes, a slight odor similar to heather or garlic is added. Some common applications of acetylene are flame heating, flame elevation, flame hardening, thermal spraying, space heating, texturing, profile coating, good bullet marking, immunization, and carbon coverings. The environmental impact of acetylene as a product derives as a damage to the ozone layer acting as a fuel. It reacts with nitrogen oxides and sunlight to form photochemical oxidants. Speaking of its reactivity, ethene or acetylene can be transformed into various compounds through the use of specific reaction conditions. In reaction with water gives an acetaldehyde. In reaction with two molecules of methanol gives 2-butane 1,4-diol. In reaction with methanol gives propagyl alcohol. In reaction with carbon monoxide and hydrogen halide gives acrylic acid. In reaction with hydrogen cyanide gives acrylonitro. In reaction with hydrogen halide gives vinyl halide. In reaction with an carboxylic acid gives vinyl ester. In reaction with an alcohol gives vinyl ether.